Next level. Next level.
There we go. Okay, it looks like we have sound now. I don't know why it took a second, but it finally found my microphone, so you should be able to hear me. Yeah, I've been having all sorts of... I was going to start this at 2, but, you know, lots of technical issues, as is the case around here quite often, and I haven't streamed for a while, so I had to move everything around. So anyways, I won't bore you with the details of that. What's going on? Nate, Mubarak, Dave, hey, good to see you guys. So we have sound, we have audio. If my cameras freeze or anything, you guys will have to let me know. I'm going to keep an eye on the audio levels. But it says video output too low, so I hope the stream doesn't look terrible. If it does, you guys let me know. There's no point really in continuing if you can't see what I'm doing, but otherwise, I do want to just kind of jump right into this and show you what we're working with. Although before I do that, you know, I had been working on a Motorola Droid Turbo 2, and I hadn't changed a microphone on one of those. And Nate, when you said it was really easy, I'll agree with you, although I did it the hard way. I'll show you what I mean later on. But anyways, let's switch over here. And check this out, guys. This is kind of cool. This is the microphone. You know those little gold boxes that you open up? Well, basically you don't generally see the inside of them, but those little gold boxes that are microphones on the inside of a cell phone. This one, I had never really looked at the inside of it before. Let's see if we can focus here. This is the microphone from the Droid Turbo 2, and there are 3 of them at the bottom. I think that one is a noise cancellation mic, and the other one is for recording video or something like that, but they're kind of interesting on the inside. The thing is, the connections, which are these 3 little dots right here, they will vary from one model to another. So the one that I had was not the correct type, although it looked very similar from the outside. You know, they'll all have a specific number on them. And the ones that I had were not compatible, so I've got those on order. However, I took the whole box off, which is not an easy thing to do because those things take a lot of heat to remove from where they're grounded on the board. Yeah, they're pretty trippy, Harvey. I thought it was cool to see this stuff, you know, under the microscope. Let's see. So to start with, I want to show you guys before we begin here what I'm working with. So someone requested that I get data off of an iPhone 6 Plus. And as you know, those phones are prone to bending a bit. And see, that's probably not a good camera. Let's use this one so you can maybe get a better view. So these phones are prone to bending, but you know, this type of bending I don't think is going to take place just because someone was a little rough on their phone. In fact, it's pretty bad. And even if you look down here, it looks like it's dented. Come on, would you focus, please? This thing never wants to focus on what we're working with. Let's try this again. There we go. Okay. So you can see down there, pretty badly bent. I've already pulled the board out because I was just wondering if, you know, man, is this thing going to survive and what part of it really got bent? And the good news is that the board's not terrible, really, if you look at it. I mean, it definitely was affected. And my main concern is that the majority of the bend or twist, which is what it really is, it looks more twisted than bent, is right down in this area towards the lower end of the phone, which I'm not as concerned about, but you know, we've got the NAND sitting right here on the back, right above the lower end. So if any of those pads lifted up under there, that's going to make this a little difficult. In addition to that, the upper shield had come off by itself. So due to the bend on this phone, there was so much stress placed on the logic board that it actually separated all of the welds that hold that upper shield on, so it was already gone. And unfortunately, the person who took it apart the first time didn't really, isn't really going to be working on things beyond replacing screens. And so they took the broken shield and set it back down inside the housing and proceeded to plug in the battery, which, you know, is obvious reasons for concern, but that's how it was when it got to me. So I'm hoping that that didn't cause any additional damage. You know, obviously, if any of these metal shields ever come off for whatever reason, you want to make sure that they're secured and reinstalled into the right spot because they will act as a conductor, and there's lots of little things that go to ground, including the shield itself. So if you touch a lot of this stuff on the outer row there, you know, it's really easy to start shorting things out. But I suspect at this point we don't have to worry about that because I've already found a short on the main power rail, which would have prevented, I think, you know, anything from going any further than that. But beyond that, it is kind of worse. You know, you always think you're getting an easy job, and then when you start looking at things up close, well, it's not as easy as you might have thought it was. Let's see. We need this one. Okay, so under the scope, I want to show you guys what I found first of all. So one thing that I thought was interesting, because I was very concerned about the processor, obviously, you know, being that the the shield came off here, we want to make sure that this CPU isn't physically damaged, at least in any obvious way, and it doesn't look like it is. I thought it was interesting here that if you take a look at this coil right here, you can tell this thing was actually installed kind of sideways. It's not even on here straight. And when I saw that at first, I thought that was due to the physical damage, but no, that's in the underfill. That's the way it was put on there. And as we rush to, get things out of the factory even faster and cheaper, we start seeing stuff like this where things are, people don't really, or whatever assembles this doesn't really pay attention to the level of detail that we used to see. And kind of started seeing that, I want to say, on about the iPhone 4 and 4S, after they went into the mass production. It seemed like a lot of the little details, like stickers being crooked and a screw missing here and there or not being tightened down all the way, started to see that. And of course, at this point, it's a game of make them as fast and as cheap as you possibly can. But I digress. So down here at the bottom, you'll also notice something else, and that is a discoloration on this lower shield. So before I even took this out of the housing, I started wondering if that bend in the board and in the frame itself are the only problems that we're up against. And I'm going to say, just looking at this shield, that's probably not the case, right? Because you wouldn't normally see this discoloration down here. It almost looks like a rusty kind of coloring here. And I don't know exactly what's going on down there, but there's definitely water damage. And on top of that, if you're able to see this at the same angle that I can, this lower shield actually broke off the weld also. Okay, so if I go in here and just give it a tiny little bit of pressure, you can see it's about to come off. Maybe you can't see, and maybe I'm looking at the wrong side of the shield. So my bad. It's actually on the back side here. So the back side of the shield is actually lifting off already. And I'm not going to poke in there too far, but you can see this thing's actually just pulling apart. So quite a bit of stress on this board. And, obviously the main thing that I'm concerned about is if there are any lifted pads under these ICs, especially the ones that are difficult to remove without damage. If that's the case, it's going to be a no-go. But on top of all that fun stuff, I started to work on this yesterday, and I decided to wait until today because I looked at the clock and I realized that I'd already done my 12 hours for the day, and so I just walked away from it. And I thought this would make an interesting stream, right? Because there's a lot of stuff going on with this phone. Up here you can see where I've cleaned, because one of the first things I found was severe corrosion here on C5202 RF, which is that VCC main capacitor that sits right next to the Wi-Fi chip, and for whatever reason likes to collect moisture. So when phones get wet, this is one of the spots that it ends up on. Here at the upper end of the board, right near the SIM card tray, down in the charge port, anywhere you have basically a port of entry. And you can see this one is discolored. And of course, when I went to check it, I'll go ahead and turn on the meter here, and hopefully it's loud enough for you guys to hear. But of course, when I check this thing, it is definitely a problem, because we got a beep here and we got a beep here. So there is a dead short to ground on VCC main. So that's where we're going to start. And of course, when I connected it to the power supply, it went to 2 amps immediately, and when I checked this in diode mode, it's zeros all the way across, and ohms are virtually non-existent. So this is my starting point. I hope that this will be a success, and I really, obviously you don't know the outcome on these until you try, but we're going to start here and hope that that's the only short, because if it is, and if the water damage isn't too bad and nothing else got bent, maybe this will solve our problem. We can power on the phone and get the data off, which is really all only thing that I'm after right now. I would not expect this to be a working phone for any length of time, even if we get it to turn on, because it's been through some serious trauma. And in addition to that, I'm happy that the person who got this first, I'm going to have to move my scope back here a sec, just a little bit. So I'm happy that the person who worked on this did not attempt to straighten out the frame. And this is another one that we run into on occasion. Let's see, how are we going to, why don't we just move this? I think I went a little further back than I needed to. Okay. So a lot of times when a phone is this bent, I suppose that, to the untrained eye, the first thing that they might think is, let's straighten it out, because that might help it. And you can imagine that's only going to cause more problems, generally speaking, because if this thing can survive a bend, if you start to bend it back, you're taking a chance that you're going to do some more damage in the process. So I'm very happy that they did not attempt to straighten this thing out in any way. It's still twisted the way it was, hopefully from the original damage. And I'm curious, I have a theory here because for this phone to be so physically damaged, and then we find moisture damage on the inside, so chances are this phone wasn't working when it got all beat up in the first place. I'm just going to take a wild guess here, and I suspect that this could have come from a user who got very frustrated because their phone wasn't working and decided that they were going to smash it to pieces, and then probably later on remembered that, oh, there's some information in there that I want, and now it's a little late for that. So hopefully we can get this back for them. And it's an odd thing, but we see it quite often, and I don't know if it could be anger management, it could be relationship problems, who knows? Maybe they really needed to make a phone call and the phone was making them upset because it wouldn't function. But we know this, if you got liquid damage and it's not working, oftentimes that ends up looking like this because people don't have, there's nothing else, they figure it's worthless at that point, so they're just going to take out some aggression on it. So here we are to try to fix that. Do we have bend marks to qualify how bendy our phones nowadays? Bend marks instead of benchmarks. That's clever, Johnny. We certainly should. I can tell you this, if it bends once, don't try to bend it anymore. I'd recommend that you don't anyways. So I'm going to find my little scraper tool. I'm loving this thing. If you guys haven't seen it, I did a video on this. This is from geekbar.com or geekbartools.com, I think. Shoot, I need to look up I always need to look up the address. So we're going to go in here and just clear off this black stuff so that we can remove, and it's going to be hard to secure this thing because it's all bent up. So I might need a different type of vise, and I'm also off of my mat here, which isn't helping. Let's see, can we come at this sideways? There we go. That might work a little better. So we're just going to clean this off. You've probably seen this 100 times because it's such a common problem. But if you have a short on VCC main or you want to check for it on a 6 Plus, this is a good place to go. And if it looks like that, obviously it needs to come off. So we're going to get some warm air. I'm going to go about 170, at least that's what my hot air says. So we're not actually melting any solder at this point. We just want to loosen up this underfill, overfill, or whatever you like to call it, and carve a little piece out so that we can take this capacitor off, which I think it might even fall off on its own now that I'm looking at it. But we don't want to do any collateral damage to the Wi-Fi chip. Again, not that it's going to work. Wow, this is really awkward because my board, yeah, see this guy? He's already lifted off, so he's dead. I was going to carve that out, but no need. Now, more importantly, do we still have a short? And I'm just gonna guess here, probably, because looking at the phone, I'm not sure this is the only spot, but we can at least test it. So that's ground, and that is also. So as you can see, removing that didn't do the whole trick, but there is a small capacitor right next to that one, and which probably didn't fail, but since we're right here, let's go ahead and take a look at it. It's going to be right over here, I believe. And I don't think this one looks too great either, so we'll probably end up pulling it off. My little stand's in the way here. Okay, so let's see. Yeah, that one looks like it might be a problem. Although they say these things don't generally fail. However, with that kind of liquid damage, see, this thing is not. Can we turn this up? Nope. That's as bright as it gets. So maybe if we zoom out, you can kind of see a little better what I'm looking at. That thing doesn't look lovely. Hey, at least it wasn't dropped in the toilet. I don't know that for sure, Harvey, so I will have some gloves on here momentarily. I hope it wasn't, but it's entirely possible. Okay, so we have a capacitor right next to that one, and I bet this one might just fall off also because it was kind of beat up, and this is really irritating not being able to steady my board. You know, it actually looks like it's on there pretty well, so this might be a hunt for a shorted component. And that one's not just popping off, but we're going to take it off anyways and see if we have our short still or not. And we do. So yeah, I kind of figured that wasn't the problem. So we will set that aside. I don't think this is critical, but just in case we need it later on. So now where do we go? Now we need to look and figure out where else this circuit leads to and what else is more likely to be our problem. So I'm looking at the back of the phone, and you can see there's one. Hopefully you can see my cursor. There's a capacitor here. There's a row down here on the bottom. But I suspect just by looking at the phone, we might want to check out down here. And I haven't even pulled the sticker off the back yet, so that's probably a good place to start. So let's see if we find anything obvious. We want overhead. See if we can find anything obvious underneath the sticker. And if you guys see something and I don't notice it, let me know. And at the end of the party, let's see, I just saw a video of a betrayed host of a party who blew the adultery of his wife and his best friend at the end of a party and ended up throwing the iPhone X of hers in the swimming pool. Fun. Nice. This is, yeah, Victor, this is an iPhone 6 Plus. And yes, backlight, good call, Nate. That was another one. And in fact, we spoke about that briefly yesterday. And I kind of thought the same thing. You know, a lot, because that backlight circuit is so sensitive, that is a good place to look as well. But I do want to take a look under this shield. I'm going to try not to make this a marathon video, but I have no idea how long this thing is going to last. But we're going to take this sticker off because, you know, with the bend and the moisture up here, I am curious to see what this looks like, and it's easy to get off. So, is that oh, you guys aren't seeing what I'm seeing. Anyways, I'm just taking off the sticker here. I think I need more cameras. And really, not too worried about being careful because, again, this phone is not going back into use. We are just going to see if we can get some information off of it and be done with it. So I'm not going to worry about preserving the sticker. However, I'm going to have to get a different board holder because this is not doing the trick. Let's see, let's put that over here, and we'll put this back on here. All right, so here's what we have. Doesn't look, I don't see anything crazy underneath this sticker, so I think that the moisture, yeah, I think that most of the moisture didn't get this far. Looks like it's mainly at the top of the board. And like you said, that backlight circuit is going to be a good candidate, I suppose. So if we look here on the front, then we can start checking what? This big cap here, I guess. Oh, that's a filter. Okay, this big cap. That's the one I was looking for right there. And that could be our problem. But it's hard to say. And I don't just want to start pulling off a billion different things. So, and once we remove that cap, I don't know if we'd have backlight. So I'm kind of tempted just to go straight to heat right now. And at the same time, I'm a little concerned about this lower shield because of all this liquid damage. And what do we have under here that we need to worry about? On this section, we are going to have, somehow I got on ground. That's not what I wanted. We want, where are you? Okay, I know you can type this in, but I'm too lazy. Okay, so here is what we have on VCC main. On the lower end, we've got this, but that shouldn't be a problem, and neither should that, because both of those are, oh, we could have this one right here though. There is a filter, or I'm sorry, there's a cap right down here, and that is right along the area where we saw the moisture. So I'm tempted to pull and look at that, because on the back side, you know, I mean, it could be so many different things. I just hate to, if it's going to be an easy one, I don't want to have to pull off the transistor, but I suppose that's probably the faster way to do it. Does painting the circuit boards with nail polish make them more resistant to water damage? That's good. All right, well, hold on, didn't we say, oh, okay, here we go. All right, is that what you think it is, Nate? Backlight cap here that's attached to VCC main. Is that where that goes? Nope, that goes to ground. You know, these don't look physically damaged. That's why I hesitate to pull them off. I do want to look under these shields though, because I have a suspicion. Oh, and by the way, over here by the NAND, there's also corrosion. How about this? Oh, well, Mike, if you let them see what you're looking at, that would be helpful. Okay, so over here on the back side of the board, we also have this right there. So there's, you know, next to where the SIM card tray was, there's quite a bit of water damage, and that is going to be nothing that is connected to VCC main. But I wonder if we have a short here as well. Oh, it doesn't look like it. I got 0.673. Oops. Doesn't want, it's not really stable though. No, 0.588. So I think that one's okay. And this is giving me 0.476. However, yeah, let's do this. I need to be able to see this whole picture. So I think we're just going to go ahead and take the shields off. So let's do that, and let me get my holder. The one thing that this is actually useful for, actually it's useful for a few things, but we're just going to put this like so. And again, not too worried about it, but I'm going to move this antenna wire so that we don't melt it. There's no need. It takes 2 seconds to move. And if you're going to stay steady, I have a feeling this shield is going to come off pretty easy, just because it's so, it's already been bent quite a bit. Let's see, I guess you guys can kind of see that. I know it's not an up close, but soon I will have more cameras, I promise. All right, so we want to go about 325 is what I've been doing, and that's been working out pretty well. I do need to get my switch set up here. Let's see, that's about to open already. Oh, we need more airflow. Hello. Just forgot. And this is a tough one. Might need a little more heat. Usually they'll come off, in my opinion, safer if you can use a lower temperature. But this shield is a little stubborn. You'll probably drop the bottom one off too. Alright, almost there. Okay, let's see if anything looks interesting here. All right, so Alright, nothing's sticking out. If you guys notice anything, let me know. But I don't think we got moisture under here. So that's kind of a good sign. Probably should have pulled this one off as well. But he did not come out by his own. So I think we're just going to go ahead and put power to this thing after I remove the transistor or the MOSFET. So let this cool down for a second. And what we need to go after here is going to be, where are you? I haven't done a 6+ for a while. So what am I looking for here? Is it this one? What do I need to bypass, Nate? Off the top of your head. It's Q something or other. Well, one easy way to find out is if you hook this up to the power supply and turn it on, you're going to feel a hot spot real quick because we know that we've got something shorted, and I know approximately where it is. I just haven't looked at one of these for a while. So let's see what gets hot. Ooh, all right, there it is. Or was. Okay, so there's something right about here-ish. Let's see, where's my plastic? Need something plastic here. I'm not poking anything. So it's right around here. Is it this one? It's one of these. Oh, look at that. I don't remember. It's near TriStar. Oh, okay. Pulling up board view. Thank you. It's right in this area, and I want to say it's one of these is it Q? Let's see if I can fill it again. Actually, we could do it with some alcohol just for fun. See which one of these suckers evaporates quick. I just haven't messed with too many 6+s other than like touch disease for so long. Is it this dude right here? Yep, I think it's this guy right here. So, sorry, I could show you. It's actually right next to Tigris IC, right? So that would be Q1403. Does that sound right? I believe that's what we're looking for. So if I'm correct, and you can check for me, I think this is the guy we're looking for right here. Yeah, okay, Q1403 below Tigris. That's what I thought. All right, so let's see if we can get a board holder that actually works. And we will bypass this because it is pretty much a switch that allows the power to come through. So when you're looking for something that's overheating, that's always going to be the first thing that does. And this board is not going to sit in any okay, I take it back. There is a good use for this big thing, and it's when your board is all bent up. It's also good for some iPad mini stuff that I'll generally use it for. The thing is, you got to flip it upside down, otherwise you don't have enough clearance to see anything under the scope. But we are going to take off Q1403, which is right here. And I want to say it's a charging MOSFET. I could be wrong in the terminology. Don't quote me. And our dot is at the bottom left, so this thing looks upright in the position that I normally keep my boards in, and in the position they're on Easy Draw and ZXW and everything else. So this will be a quick one. We're just going to pull this and we're going to bridge the positive and negative, or the source and the drain, together and bypass the switch, and then that way we should figure out what's getting hot on this board. So let me get my fan back on here. And if you take a look here on the schematic, actually, if you're curious, you'll see that we have VCC main on all of these. Let's zoom in here. So all of these are VCC main, these red dots. Over here, C3, 2, and 1, or C1, 2, and 3, these are all going to be for the battery. And this A1 here, that would be your switch. So this is what tells this thing to turn on and off and allow the power to flow through. And what we're going to do is we're just going to bridge this set of red dots over to this set of red dots and completely bypass that switch that's down in the low corner. And that will allow the power to flow through so that this thing doesn't overheat, and it sends the heat hopefully to where the affected component is, and that will narrow things down. At least that is the idea. So we'll find out here in just a second. Go ahead and get this dude off. And this is an awkward position to be in. Let's see. I'm going to have to make this slightly easier for myself because I can't reach around all this stuff at once. We'll see. Can we do it this way? Oh, don't bend your tweezers, Mike. No, we can't do it that way because then we can't see the camera. So let's see. Maybe if we come in like... Where'd you go? I lost him. Okay, maybe if we come in... Maybe if you let them see what you're talking about, it'll make more sense. Okay. It's going to be awkward to grab a hold of, but it should be able to make do. Okay, so we just want this guy to come off by himself. Let's see. Zoom out. I'm telling you, it's so hard to position this camera to where it doesn't get dark. And I've tried all sorts of stuff, including the software that comes with it, and not much luck, so. And my poor heat gun is dying. How much higher do I have to go with this thing? It does not melt anything anymore. I think I need a new heating element. Alright, so that's off. We'll set that aside for the moment. And let's go ahead and turn the iron on. That one might not be a terrible idea. Let's see, that's way too big. Let's see if one of these newer irons is going to work. I think it's time for me to upgrade all of my equipment. At this point, things are wearing out. What's up, Caesar? Oscar, hey guys. iPhone 6, it just reboots, put a new battery in and charging port, and just boots up. Okay. New battery in and charging port and boots up. I say it on the bottom of the board next to Tigers. Okay, yeah, you guys all called that one before I found it. That could be a few things, Caesar. I would think something in the charging system. A bad battery can actually cause that. And then, of course, problems with TriStar and or Tigris. You know, with that much information, I'm not sure I can really give you anything definitive. But I would try another battery and another charging port just to rule those out, just in case. And this is not cooperating. Yeah, I don't know what it is, but my iron is not getting hot enough anymore. But let's just go ahead and get some leaded solder on these dudes. That's a bit much. Caesar, do you have a TriStar tester? Because that would be just a very primitive way of ruling out a few things before you have to dig too deep into there. That's one thing I recommend. If you don't have one, they're pretty handy. Otherwise, you can take the board out, or you can open up the phone and check. Yeah, see, this thing cooled down too much already. But look at that. I just made a bridge that would actually work. See that? So this is what we wanted. Let's see. I don't know if you guys can see that, but I just put a big old blob of solder on there, and I'm not even going to bother with the jumper wire because this will do the trick. We are now bridged. So this phone will charge even if it's not told to do so, and that's what we wanted to accomplish. So now hopefully we can find the source of the heat. How good that, how good it, that boulder, what? Having on the way, try updating with a good battery. Holder, sorry, big thumbs. Okay. How good is that holder? You know, it is It is heavy, so it doesn't move. I mean, this thing weighs, I don't know, 7 or 8 pounds, I think. Maybe less, maybe it's 4 pounds, but it's solid. The thing is, if you use it the way it's designed to, and you can actually move this, you can elevate it, make it go up and down and stuff, and you just open this up and it clamps down on the board. It's got a nice little rubber pad in there. It's great, but it takes up this much room from your workspace. Between that and your microscope, you know, for us isn't going to work. So I generally end up putting the board in and then turning this thing upside down. So it's okay, but I got to say, for what it costs, I'm not convinced it's really worth it. I don't use it that often, and there are other things that probably work just as well. And I hate to say so, as much as I hate them, these things actually work for a few things, you know, when we don't have a custom board holder for whatever it is that we're working on. So I definitely get one of those. The Omnivice, I don't know, I'm not really sold on it. If I went back in time, I probably wouldn't have purchased it. But when you have it on hand, you're going to use it, right? Okay, so now what we want to do is find out what the real source of this heat is. And again, this isn't pretty, guys, but it is bridged together. And that's what we were after, having these 3 or 5 reds making contact with the 3 on the right-hand side. And we've accomplished that. So I think we're good here. And no, I'm not even going to worry about cleaning it up, because all this stuff is not for long term and we're not done with it yet. I just want it to work. So now, when we plug in our power supply, we should get a different hotspot, I hope. And we do go straight to 2 amps, so we're not going to have any shortage of heat. And I'm going to kind of feel around and see if I can tell where the heat is coming from. And hope that it's not the processor or anything else important. Okay, I am not feeling, and this pulled it down to 0.88 volts. And it seems like, yeah, I'm not really feeling anything. Let's see, which way I need to go to focus? Up. Okay, so we have our short, but whatever it is, with, you know, pulling it all the way down to 0.89 volts, I'm not really getting a noticeable hot spot on here, which is what I'm after. Good news is the NAND doesn't feel hot, the CPU doesn't feel hot. So I think we're looking at something elsewhere. We can try freeze spray, because it's going to show things that we wouldn't normally be able to see. And of course, Nate, if I had purchased some of that smoke stuff you were talking about, I'd be using that, because that sounds like it'd be fun just to experiment with. But I don't have it. So let's see if our freeze spray is going to reveal anything. I have my doubts, but we may get lucky. So we're going to try to get this all on screen, or at least most of it. And let's just spray right there, hit the power, and just starting to warm up from the top. I don't see anything in this section of the board. So we will get some heat, obviously, as it's booting up, but I didn't see anything right away. So I'm going to go up here to the top. Let's get this. I thought I took this sticker off, and it sat itself back down. There's only so many places our problem can be. Boy, that thing really stuck back together. Come on. I'm just going to peel this dude all the way off. This time it's hard working with these gloves. Come on, really? Okay, let's try this again. So now we can see most of the upper part of the board on the back side. We'll stop right there and let's freeze it again. And power. And nothing so far. There is a little something in the corner of the PMIC, but you know, that I think is just because it's booting up. So unless there's something right around here, and there's not a lot of heat, so I'm not really worried about using the freeze spray right away. It's not like we're going from super hot to super cold, because this thing is not getting very warm. And I suspect that's because, probably because of where the short is located. But let's see what this does. All right, nothing in this vicinity, so I'm going to guess other side of the board. Probably. The smoke is not practical for the whole board. Oh, okay. My iPhone SE needs a new battery. Where can I get a good quality battery? Ugh. You say 380. What are you talking about? C380? Victor? If you have a guess, I'm willing to check it out for sure. C380, I'm guessing. That's what you meant. Okay. So apparently there are several of those. If this is what you're talking about, let's see. We got C380. Oh, okay. And where else do we have a C? Oh, no, we have C. My bad. You said 380. I put 3801. Is that what you're talking about? Oh, well. I think we need to check on the other side. And maybe we'll get something up here near the top. But I have my doubts. I think we're going to just have to crank up the amperage on this thing. Hey, Dave Hammerton, 11:15, early start tomorrow. All right, hey, man, I'm going to do one of these late at night here one of these days so that it will be in the middle of your day, hopefully. But thanks for stopping by. I appreciate it. So let's try up here. And see if we get anything. Nothing is melting, at least not quickly. Yeah, I think the only thing that we see melting is just the normal boot up sequence. So it could be underneath this lower shield, but I'm going to turn up the amperage a bit because maybe we can get a decent amount of heat. Let's go with, actually, let's go 2.5 and see if we can feel anything. I said 2.5, not 2.4. All right, so now we have 1.07 volts. Man. I think there's a little heat towards the bottom of the board is what it feels like, but that can always have to do with being plugged in there too, where the power's coming in. Yeah, it's not really significant, so we'll turn it up a bit more. And then, yeah, I'll probably end up just pulling that bottom shield off too. Could be something down there. All right, now we have, whoa. Oh, I see why. Okay, 1.64 volts. So yeah, it's just not, oh man, you know, I think it might be underneath this front shield. But again, that could come because, that could be because I've got the power coming in right there. But that's the only place I'm feeling anything even remotely warm right now. So I think I'll go ahead and take the shield off because we can see that, you know, from the discoloration, this thing's definitely been wet down here. I mean, it's got like a gold color to it now. So this shield's kind of a headache sometimes, and it's easy to nudge things off. So be careful if you have to pull one of these. It's not fun. I came in one time and forgot that I had my heat gun on shield removal temperature and went to replace a component down in that area and just blew everything off. Blew a bunch of stuff off the board. That was fun. All right, so this one we'll do under the microscope. And again, I'm using the, I want to call it the Nate method because that's where I heard it from. Got it from. But if you come in at the corner and get your tweezers inside here so that they're kind of trying to open, this thing will just open itself up when you get it hot enough. Actually, I might, yeah, we can start here, I think. So Nate, I don't know if you came up with this, but I like it. It works. Thank you for that suggestion. Okay, so we need to go back to 325 and 60 on the airflow is what I'm using. And let's get this fan on just for the heck of it. Now, I used to come on these things really hot and fast, but I've noticed if you come in a little lower, you know, like I said, temperature between 250 and 325, depending on what you're working on, it will melt this solder and I think it's a little safer as far as the other components are concerned. That's just my philosophy. I have yet to damage anything that way. I feel a little safer about it because we don't really need 500 degrees on this shield, although that does work too, so I guess whatever gets the job done. I need a little more airflow on this side. Man, this thing is always tough. Alright, this one's gonna be fun. Alright, I think I'm going to start down here at the bottom. Alright. Phone, you're gonna make me look bad here. So I might have to go a lot hotter on this thing. And back shield came off easy. Okay. I think it's also because my hot air station's getting a little old. I usually need max temp and max air to remove that shield. Yeah, you know, I've had pretty good luck without going that hot, Nate, but I know this is a tough one, so if I have to, I'll turn it up. But right now, I'm suspicious that my hot air is not the temperature that it says that it is, because I've been having to adjust things for so long. I think you may be right, though. This isn't doing it. Usually I can get them off, but this stuff's just getting soft. We'll see. There we go. So we're getting close. Alright. I'm going to crank it up. Boy, I think you're right, Nate. I'm not getting anywhere. Darn it. Alright. Crazy. Uh-oh. Starting to burn my battery terminal there. I hate coming in this hot. Yeah, I'm really starting to wonder about my hot air station. We should be off long ago. Yeah, that's taken longer than I expected, and I don't generally have that happen. You just take the nozzle off. Sucker's stuck. Oh, you know what? While we're at it, though, I could show you guys another little trick that I've been using, just because this thing's being so stubborn. And if you don't happen to have a hot air station, you can get these shields off. Come on, get this thing to sit. Done the iPhone 7 Plus again? Jeez. What's that, like the 5th or 6th time? I think at some point, maybe use that as a parts phone. That's a bummer, man. I know you spent a lot of time on that already. What I was going to show you guys is what you can do, although it's a little more work, is if you don't happen to have a hot air station, you want to get these off, you can do it with an iron. And it's going to be tricky to show you. So what I usually do is take my big iron, heat up the edges, and you can actually lift this thing apart without even using the hot air at all. And it's probably safer, a lot more time consuming. I don't know why this one's being so stubborn, but you know, since we're after data, and because there's an opportunity for this, what you can do is you can put a bit of flux along the edges here. And this is what I did with the Samsung, where I didn't want to just superheat it. You see, I've already kind of I'm sort of melting the battery terminal with the heat. Not good. I mean, we can replace it if we have to, but I'd rather avoid that. But these things will actually lift up, except for the ends, obviously. And you can kind of detach them. Although this one's not going to cooperate because of those bottom pieces not being off yet. So, let's see. I'll try something else here. Works better on the upper shield. Yeah, I don't think that's going to happen on this one. It does work on the iPhone 7 upper shield, though. I think I'm just going to take my nozzle off and do it the old-fashioned way. Let me get my glove. Or at least a bigger nozzle. All right. Cooperate with me, phone. Boy, I have never had this shield give me that much trouble before. That's crazy. I actually floated the charge port a bit there too. And we got some solder right here, which is not intentional, but let's get that out of the way. That was fun. Look at that. I've got to get this guy back into position. And actually, I could just go ahead and replace the whole thing, I suppose. But we should be able to straighten it out. I think he's still usable. Before I have to go to the parts bin. Let's see. Let's come down a bit on our temp. And we should be able to get this thing just to go back to where he needs to be. Hopefully that's enough heat. Well, I have a bigger nozzle on here now, so that's going to make it not as hot. Okay, right about there. I think that's straight. We will find out here momentarily. The short magically disappeared, then we know I messed up on the battery terminal. Let's try this off of here. Nothing funny looking. I thought I was going to see something like burnt under here or destroyed, but I don't. So that's odd. All right, that what I said. Bottom shield. It was a heat gun. Yeah. Yeah. You know, I got to tell you though, I've taken these things off before. I don't know. In any case, it's off now. So let's let this board cool down for a second. I should have kept the fan on. This heat gun, or this hot air station, is not giving me the same temperatures it did very recently, so I'm not sure whether to just go ahead and replace the heating element or to calibrate the system first and see if it will work properly. So if anyone has a suggestion on that, I think the consensus is to just go ahead and replace the heating element and then calibrate it, but it doesn't seem like it would not be a bad idea to do both, right? At least that's what my logic says. Okay, so we still have a dead short, so definitely the battery terminal is still working, but is it going to reveal itself is the question. I guess we could always check right here, see if anything's getting hot on this side. All right, that's nice and cool. Definitely wouldn't expect it to be on this side. Yeah, I think that was just the charger connection getting hot. But it looks like there's nothing heating up here that I can see. So now what? Hey, SG Wally. What do you guys think? I don't want to just... let's see if we know that... We know that we have a short here somewhere, but nothing's getting hot. So might it be something further down the line is my question. Or could there be corrosion under one of these? But again, we should see some heat on here, so I guess might just turn it up a little bit more and hope that it reveals itself. I have a strong suspicion it's somewhere down here at the lower end of the board. But obviously I don't know that. So I'm going to go 3.5 amps. See if anything happens. Okay, so we're getting 1.54 volts now. And I think there is some heat. And I think it's at the upper end of the board. Somewhere. Yeah, I think we're getting heat. Oh, let's close this. I think we're actually getting heat up in this vicinity here. So let's see if we can track that down. I think. You know, it's always hard to tell. But yeah, I think we're coming from the top end of the board. So I'm going to let this cool down for a second. But It's funny, I had one like this recently and it's actually kind of under the shield, or under the exoskeleton as you call it, Harvey. Could it be this guy right here? I wonder if that is our problem. Nope. Doesn't look like that. Doesn't look like that should be it. In fact, there's nothing on this side of the board that should be getting hot, unless it's the audio. Is that the audio codec? Oh well, we shall see momentarily. Alright, I think it's up in this vicinity. I wonder if the Wi-Fi is bad. Okay, let's try this. Alright, so the only thing that I saw, which you guys didn't, because you can't, I will show you one more time. This corner of the power management, keep an eye on that. This is the first thing on this side. And it does take a second, but you can see up there in the corner that that is melting. And where does that go? Let's take a look here. Okay, so we do have VCC main going to button AP to ringer. Empty. Ground. There is ground right next to... Yeah, there is ground right next to that corner. And then button to AP ringer. And of course VCC main is right next to... Oh, no, it's not. I take it back. It is not next to ground in that area. So could it be something on the opposite side of the board? If it is, then it is probably the CPU, and that's not what I want to hear. But it could also be a backlight issue, as someone... as you already said, Nate, because if that diode, everything looks healthy though, but let's see if anything lights up right here. Do we get heat? That's a little too fast, I think. Too fast to tell. All right, let's try this again. Yeah, I'm not seeing anything up here. It takes a long time to reach this point. Is my PP1V8 short? Yeah, I'm pretty sure it is. I was hoping we could relieve the VCC main short first, but yeah, when I checked it yesterday, we did have a short. Let's see, where are you? You think that that would just make it show up as being on VCC main then? Because this, which is PP1V8 on the left-hand side there, that one, I'm sure it's still short. At least it was yesterday before I pulled these two caps, so let's take a look. Yeah, so 1V8 is short. For sure. When you heated the PMIC, the 1V8 part got hot too. Yeah, so maybe we can track that down first. So we would have to inject voltage onto PP1V8. But before I do that, I want to take a look at all of this garbage right here. Actually, let's just give this a little cleaning. See, it doesn't go to anything in this area. It's all the stuff up above it. So any of these might be damaged, but I don't think that they are. But I'm still going to wipe this down anyways because there's a bunch of nasty stuff on there. And what is that exactly? And you know what? I checked this line, though. This line was actually good, right? I'm pretty sure. Because it does have like a sandy bunch of garbage on it. Let's see, that's no stuff. So the one right here that I'm looking at, this is PP1V8 Oscar, but it is not shorted. However, it's got a bunch of crap on it, like caked on there. So we really had a lot of moisture on this area and corrosion, which probably led to this whole situation. Because somebody said the iPhone 6 was water resistant at some point in time, I'm sure. All right, let's see. Let's just make sure that it is not Oscar. Not you, Oscar Zarza. I'm talking about PP1V8 underscore Oscar. 408. Yeah, so actually that looks okay. Looks about normal. So Nate, where would you guess, or anyone else, if we want to look for a 1V8 short, because I think it's in quite a few different spots. I mean, again, we could go back to heat, but then I'm going to have to solder a wire. I guess I could solder a wire right here, right? Let's do this. No, let's do that. Okay. So this is that's our NAND. So this is our PP1V8, and it is shorted. So we can probably come in, let's see, I want to say right here, because we've got two things that aren't even actually there. This is not there, and this is not there. These two components, those apparently are no stuffs. But this cap is here, so we can come in and solder a wire right there, and then we'll inject 1.8 volts. Right? Am I missing anything? Would that be the next logical step? I think that's what we want to do. So let me get a jumper, and let me also grab my little clamp-on thing here to save time. I don't see the advantage of soldering a wire to your to anything really, when you can use these little clamp-on deals and just attach something to it. In fact, this straight pin works just fine. And we've got another one for our power supply right over here. So we will set this on like so. And make sure this is actually working. Yep, okay. So let's bring our current back down. We don't need 3 amps going through 1V8. Bring that back down and just make it 1. I don't know, how many amps do you put through a 1V8 line? Probably not a lot. I think your earlier thoughts are correct. Release the VCC short first. Yeah, but how? Because since we can't locate it, you know, and I'm hoping that it's not underneath something, do we continue looking for corrosion? Where do we want to go from here? You get off there. There may be something that we can see. These don't look particularly healthy. And this, what is that? I don't know what got in here, but it's kind of like a gold colored liquid. Look at that. It's completely, oh geez, Mike. I need a cameraman here. So this thing was coated with some kind of gunk that's the same color as the rusty looking stuff on the other side. I'm going to check a few things around here just real quick. Just for fun. Look under U1501. Okay, I can do that. Let's see if anything else looks funny here though. Because this thing could be full of problems, you know, based on the physical damage. Is that VCC main also? Oh, that is PP bat VCC. Did I just overlook something very obvious, Nate? Guys, everybody. So this is for the battery, which is on the opposite side of VCC main. So maybe our short, and why didn't I check when I had the when I took the MOSFET off, why didn't I check and see which side the short was on? Because that would have answered my question. I bet you the short is on the battery line. That is my guess. I'm going to remove this solder so that this is no longer bridged, and kick myself for not doing this the first time around, because this is normal procedure and I didn't, you know, you get wrapped up in making a video and you stop paying attention to the obvious. So I think this is the place to start. We need to know, because now that VCC main and VCC bat are tied together, with that transistor in place, wouldn't that have prevented it from showing that way? I think. Well, we'll find out. We definitely, or is bat now shorted because we attached it to main? Probably. That is probably what's going on, right? Am I wasting time here? Tell me if that logic makes sense. I'm going to go ahead and just pull this off because it's easy to do, and I want to put my mind at rest. Wrong iron. You bridge Q, that's why it's short. Okay, all right, that's what I thought. All right, so I still regret not checking to see if there was a short on VCC bat before I bridge those two together. But yeah, I agree. That makes sense. Now it's going to be, your guess is as good as mine. So U1501. U1501. So what is U1501? Oh, let's type it in, right? U1501. Okay, help me out here. What is U1501? 1401 is Tigris. 17. You know, I will agree that trying to search on easy draws a little trickier. You're trying to find something. 5300. 15301. What is U1501? I need to redo this color scheme so this thing's easier to read. Oh, Chestnut? Oh, okay. So what makes you think Chestnut? I mean, I'm open to suggestions. I'm just curious as to how you arrived at that as a suspect. Because Chestnut, let's see, what does Chestnut do? Oh, not that one. This one. Okay, so Chestnut is going to be on the backlight circuit, right? Let's see. Oh, where are you? Okay, there is one VCC main on Chestnut. And it goes to the PMU, and it is not sitting, oh, it is sitting right next to ground. But you think it's shorted internally? Okay, it has VCC and one V8. Okay, well, why not? I mean, what's the worst that can happen? It wouldn't work, right? So Chestnut it is. I'm telling you guys, I want to start taking bets on this stuff, so that way if somebody guesses it, you know, I don't know, win something maybe, right? That'd be kind of cool. Because in many cases, it comes down to taking an educated guess of some sort, since there's not really much in the way of an instruction manual. Okay, 1501 is, okay, that's the lower one. Okay, let's get to where we can see. Oh, okay, you're on the same screen I am. All right, top right. Oh, really? You want me to pull the one that has all the underfill around it? I kind of don't want to do that. Darn it. Why do they have to do this? You know what I do see, though? See some little balls of solder right here. Look at that. Can you see those? I wonder if those are just from manufacturing. You see right here? There's a little ball of solder there. And right next to this one, this little tiny cap, there's a ball of solder right here. Couldn't we pull something else in between Chestnut? No, I guess not. See that? There's a ball of solder stuck right in there. And I wonder, you know, the 6 being notorious for backlight issues, 6 plus might be too. That looks a little funny. Okay, so we do have, oh, that's because I'm on VCC main, of course. Oh, man, I hate to do that. Just because of all that underfill, it's going to be very time consuming. I guess maybe that's the right course of action. I was thinking, couldn't we pull off a filter that would, but it does go straight to VCC main. Ah, Nate, I don't want to do it. Darn it. That means I got to carve all this stuff out. All right. I really hate the way that they did this. You can check the connector to see if any other lines are short. Well, yeah, I suppose that would work. Look at this. Look at this right here. How did I miss that? This connector is trashed. If that is a ground touching what is on there? Let me, before I speak, let me take a look here. So that is on the 1, 2, 3, let's see, 1, 2, 3, 4th and 5th pin on J2019. So 4, that goes to APLCM MIPI data, and 5 goes to ground. So are these two connected? I'm curious. It looks like they're it looks like they're touching each other. They might not be, but they're sure mangled. Nope, they're not touching each other. But that pin is pretty messed up. It is isolated though, so I guess that's not what we're after. But man, somebody really jammed this. Look at that. This thing is shot. It's not even connected to anything. Wow, guys, what are we doing here? All right, so yeah, I'll check and see if we have anything else that is not supposed to be going to ground over here. All right, so I know some of them are supposed to. That is one of them. 3, 4, 5 is gone. 7, 8, 9. 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9, 12 should be ground. 16 should be ground. And then 3 more. 1, 2, 3. Okay, I might have found something right here, although there may be an easy explanation, so let me double check. So this lower left-hand side, let's see. Yeah, so this should not be going to ground here, this first pin. And it is. And that is PP1V8 LCM. So, okay, fair enough. I think we may very well have a problem, Houston. Okay, what if we take off, now take a look at it, follow me here and tell me if I'm crazy. I think that what we can do is just go ahead and remove this filter. So FL, no, because it's still going to get to ground through one of these, right? So what about checking FL 2027 on both sides and then removing it and seeing if the short changes at all? Will that make sense? I want to make this as easy as possible. Okay, so you're number 3. All right, so let's get this dude off here. I need to change my nozzle on my heat. Okay, so this should be our filter right here. I'm just going to carve this out in case we decide to pull him off, because I could be crazy, I could be wrong for sure, but I wonder if we can isolate. You know what, that's not going to make any sense though, because the only place that it goes to is the adjacent capacitors, and I just cleared out the wrong area. Hello. Okay, here's our filter right here. And I suspect that if we take it off, nothing will change because there's only a couple caps sitting right next to it that could have been a problem. And I doubt that they are. But this is easy to do. And my philosophy is do the easy thing first. At least you can rule that out. If it's not time consuming, you're not, you're not adding to the amount of effort that you have to put into the repair. So let's get this thing back on here. So sorry, you weren't even able to see. I gotta tell you guys, it's tricky to keep track of what's on camera and pay attention to this at the same time. So we have a filter right here that goes to LCM. It's PP1V8 on one side, and it is PP1V8 LCM on the other. So at least if we remove this filter, we can tell which side the short is on and hopefully save some time and energy. Man, this thing has got all kinds of stuff, garbage stuck to it. It's the thing about flux. All right, so let's see if these tweezers are going to cooperate today. You can also check the connector. Yeah, okay. I'm going to do that, but first I want to pull this off because I have a feeling at least we can hopefully isolate which side the short is on here. That's my philosophy. All right, let's take this dude there and set him right there for the moment. He's not going to stay. Okay, well, you're going to need a new filter because I don't know where that went. It happens. All right, that's ready for a filter when we get to that point. Oh, look at that. Ha ha ha. Okay, so what have we learned here? Basically that they're still short on PP1V8, but there's not a short on PP1V8 LCM, which again didn't really narrow much down, right? Because the only place that goes is to the connector and to a couple adjacent caps. So, all right. Could that have been what killed PP1V8? I wonder, maybe. All right, so now we want to pull Chestnut. I hope you guys are comfortable, because this one is never fun just because of all the garbage that's surrounding it. So we're going to be right next to the CPU, putting enough heat to get the underfill off. And if you ever have to do one of these, I highly recommend you get one of these tools. I don't know if you can see it, but this thing is like a miniature medieval weapon of some sort. It looks like one of those curved blades, like a scimitar or something. And it works pretty well for getting into these small areas where you really want to get this underfill out of the way so you don't cause any damage or pull anything out with them. Again, these are Quinley, I don't know how to pronounce it. All right, I guess let's do this. Darn it, I was hoping I wouldn't have to. Oh, you know what? I need to change my nozzle real quick. And now my glove's all messed up. Okay. Just come off. All right, so again, we're going to come at about 170. I've been going up as high as 190 on these. I will put a heat sink on the processor. I don't think it's a big deal, but, you know, better safe than sorry or something like that, so they say. Don't want to damage that dude. But we're really not putting a ton of heat here anyways, and we kind of have to just score this thing like an orange. Hopefully not damage the chip, but at least those we can replace if anything goes bad on it. So Nate, you're thinking that this thing shorted internally, I take it, right? Because it's pretty well protected. I don't think there's any chance of moisture, at least in this case, that moisture got to it. And we'll try not to cut down into the board. Okay, this is the easy stuff here on this side, relatively speaking. Okay, so that's pretty clear. This one right here, not going to be fun because these things are literally touching each other, or almost touching each other. So getting in between here, really need something super thin. I just don't want to pull off another chip in the process. You know, we might have to replace this chestnut anyways. He could get mangled or be defective. Might be broken already. Okay, I think we're pretty good here. Now the fun part is, I bet a lot of this underfill went beneath chestnut, which doesn't make our lives any easier. So, let's see. I think we're pretty clear for the most part. Keep that right there. Flux. Alright, a little more heat now. Oh, and where is our orientation? Oh, I can always check the schematic, I guess, right? But I did not pay attention, so let's see. Alright, so dot is on the top left-hand corner. Oh, and I need to come up on this. Well, that's going to be fun to grab. I almost feel like flipping this up might be a better way to go about it, but let's see. Come on. Yeah, I think we've got some underfill here because it's wanting to come off, but it's a little stuck still. Everything else around it is, so that's fun. Alright, so we got one cap that got knocked out of position. Straighten this dude back up while it's warm. And our threaded barrel is almost gone, but we don't need that. Not for this job. Come on. Oh. Alright, let's just take this off. What's going on here? Need some flux. Come on. Ah. Darn it. Stay. Alright, so this needs to go. You're just in the way. Don't need that for anything. And this, I'm not too concerned. I know it's not perfectly straight, but as long as it's attached, we'll come back and heat that later. More importantly, do we still have a short, right? That's the question. And where were we looking again? Oh, we're looking over here on the side of our filter. And guess what? I don't have my beep mode on. Just change this back so you can. There we go. Okay, so we still have a short on 1V8. That is unfortunate because I really was hoping that would help, and that didn't do the trick. And you can see I cut into the board a bit, so we have to go back and patch that up. It's interesting. This coil looks kind of funny. There's like, almost looks like there's something coming out from underneath it right here. That was the crooked one I was talking about. I don't know what that is. Doesn't seem like it should be there though. I think it's solder. Is VCC clear? Let's find out. The way my luck is going today, I would venture to say probably not, but that would be a step in the right direction, so I can hope. Can always hope. All right. VCC main is still shorted. PP1V8 is still shorted. What else? Probably not the only thing at this point. Just wondering where else we need to go from here. You know, just based by virtue of the fact that there's not enough heat to tell where it's coming from. Unless it is the PMIC, which would be a real bummer. And, you know, as far as physical observation goes, there's not a whole lot on that line that's just sticking out and looking obvious. Didn't you have one like this recently? That end up being PMIC? Seems like. Oh boy. Well, I hate to do something without a conclusion, but at this point, I'm getting a little more skeptical about this being a fix. That's probably going to be a low resistance line. Nope. Yeah, it is. All this stuff around here is generally going to be super low. CPU and GPU lines. Well, what if it's something weird like, it can't be TriStar, it could be, you know, with the moisture and people plugging things in, maybe Tigris? Is VCC clear? Yeah, no. Any other guesses? I'm about to, I mean, because there's no heat. That's what's killing me. And let's see, and Tigris has VCC main sitting right next to ground. We know that there was moisture right on the opposite side from where that sits. So maybe we have some moisture damage, and I mean, heck, it's easy to take off and take a look, right? Opinions? And I actually had one recently that had a bad Tigris that caused a short. That's why I'm thinking maybe. Am I overlooking anything? I think that's going to be my next move, just because it's easy to do. I wish this board was flat. Because without the heat, I mean, unless I want to accept the fact that the heat is coming from the PMIC, and I really don't, because at that point it means everything got much more difficult and less fixable. What else am I missing? I feel like crank up the amps and look for heat again. Well, I'm at 4 amps right now. Do you think I should go higher than that? I mean, and when the heat does show up, it's under the PMIC. So that's the first place that it's going to. I think we're just going to create more heat right there. I'm going to pull this just because I've seen something like this before. And maybe it got water underneath here. Does that make sense? I'm probably going to be wrong, and if so, and if it goes past, oh, it's already 4 o'clock, geez, guys. I'm afraid this may end up having a part 2. It's not what I was planning, but it is not an easy one today. But I'm going to pull this off just for the heck of it. I've seen a short on VCC main caused by Tigris before, and at this point, I'm kind of guessing. Looking for the most likely suspect, I guess you could say. The heck is that? That little ball of solder off of there, killing me. I'm at 410. Hello. Hot air doesn't do what it used to. By the way, there's quite a twist in the board in this area also, close by, so. Yeah, my hot air is just not doing the way that it used to. Well, no moisture. That's a bummer. That's way too big. Or the PMIC will short in the case of water damage. like water damage being elsewhere, because there's not really water damage that I can see in that area. Of course it could be, who knows? I mean, stuff gets everywhere, right? Just never know exactly where it went. Let's see, solder. Oh, you're not going to melt, are you? Unless I get some solder on here, and that's too much. You know, one thing that I discovered just through experimentation is that all pads are not equal. So you have the real sensitive ones, like, you know, under the Touch IC and under the Audio IC on the iPhone 7. The pads under Tigris, pretty durable. They can take quite a bit and still keep going. So if that helps anyone's knowledge database, it's good to know. It's hard to really damage these. I made a mess of these, but at least they're not all connected to each other. I think my tip is going bad too. Just not enough heat these days. Alright, so let's see if that changed anything, and I doubt that it did. And if not, I think I'm going to have to call it for now, because I've got to pick things up. But I suspect we still have our short, because I'm just not that lucky. Yeah, still got our short there. That's a bummer. And if it's this, do we have moisture under this thing? Oh, so the PMIC is all exposed. No underfill. But at the same time, I don't see any signs of moisture here. Nate, I will give you a call later. I'm probably going to have to take off here. Maybe there's some heat underneath the edge of one of these rails somewhere. I've seen that happen too, and it's just hard to find because they're kind of hidden under the exoskeleton. So I'm probably going to have to go back and look through here again, but right now I'm out of quick fix ideas. That's too bad. I was hoping this would be a winner, but it is going to need some more work. Could be any of these dudes too, you know. But when we start guessing, then a lot of times you get pretty deep into these. No luck. I was hoping one of these would just feel like it's ready to pop off, you know? Sometimes they do that. Well, I don't have the answer today, friends. I am going to work on this further. If I don't live stream it, I'll definitely come back and tell you what the outcome was. But at this point, I'm also a little concerned that there could be something, you know, internal to the board that is damaged because it was so badly twisted. And it's all kind of right in this area, well, basically below the NAND, kind of right around here. So, yeah, it's a pretty bad bend. See if you can see it under here. What? Stop it. Okay, if you take a look under the scope, this is what I'm seeing right now. So we can get back far enough. So there's quite a bend right in that vicinity. Maybe it caused something to go where it wasn't supposed to be. But we have that plus liquid damage, so all possibilities are on the table, I suppose, on this thing. Question is always like, how much more time do you want to put into it? Anyways, I'm going to end the stream. Sorry, guys. I was hoping this would have a happy ending, but that's certainly not the reality. You know, a lot of these end up being much more complicated than we thought they were. I've had several where we have this capacitor right here. It's shorted, you take it off, and problem solved. But that's not the case today. So there's a little more little more groundwork we have to do to kind of track this thing down. So if and when I find the answer, if I don't do it live, I'll definitely let you know what it ended up being. Right now, I got to get to the mailbox before they close and pick up my fresh repairs that are coming in. So I don't know, if something else comes in good for this evening, I'll start another stream, and if not, possibly come back tomorrow. But I am going to take off. Can a NAND transplant work to recover the data? I don't think so, Johnny. My understanding is, you know what? I don't want to say that because I've been reading some things that say differently, and I thought that the NAND had to be reprogrammed or reflashed to match the motherboard that it was with, but that may not be the case. I think that you can extract data, but it's encrypted. But if you transplant it, maybe? I think so. I saw the other day Jessica Jones did a CPU transplant. Yeah, those are fun. I haven't tried that yet, and I'm not sure that I'm going to anytime soon. But definitely some risk involved there. I think I've watched her attempt one. I don't think I saw I'm assuming that one was successful. Yeah, I was gonna say I thought it was NAND, EEPROM, CPU, and baseband, right? Don't all those have to go together? Depending on the model of the phone, I think that changes each generation. I saw that one that she did like for some musician where they were trying to recover his data, and I think they tried to transplant either the CPU and or the NAND, and I don't think it worked, but maybe she did it successfully more recently, which would be cool. Be good to hear. But again, I think they all come down to, I don't know, maybe. I mean, how did it turn out? I saw the other day Jessica Jones did a CPU transplant. Well, if it worked for Jessica Jones, and if somebody in China did it, then we know that it can be done, right? But I certainly haven't tried, and that's one that I try to steer away from, moving CPUs, NANDs. I've done some chip-off stuff with older Androids, but with iPhones, man, there's a lot that can go wrong. But I guess nothing's impossible, right? Anyways, I'm going to get out of here before I make a bigger mess. And again, if I figure this thing out, I'll come back and let you know what it was. And if not, I'll do a part 2 live stream and keep digging, I guess. Anyways, thanks for the views and the suggestions. And if you like the video, please hit the like button. That helps me out a lot. Outside of that, I will talk to you guys next time. Have a great rest of your week.